Alright guys, here's a quick example from the Zumdahl textbook on page 173, question number 53. So in question number 53, it says a 1.42 gram sample of a pure compound with the formula M2SO4 dissolved in water and treated with an excess of aqueous calcium chloride, resulting in the precipitation of the sulfate ions as calcium sulfate. Alright, so from the information so far, the first thing I think we should do here is set up a balanced equation. So in our balanced equation, M2SO4, where M represents our unknown metal from group 1, we're told it's a solution. We're going to combine that with calcium chloride, so that's CaCl2, and it's an aqueous solution. And on the product side here, we've got calcium sulfate, that's our solid, and we have 2 MCLs. So we have our balanced equation. Next, let's figure out how we're going to solve for the molar mass of M2SO4. So one thing that we know is we know that 1.36 grams of our precipitate in the end is recovered. So we have 1.36 grams of calcium sulfate. That's the precipitate we recovered. So that's our known. Let's convert that into moles. So 1 mole of CaSO4. Okay, now I looked this up before, just a quick rough one. 136.14 grams, I believe. Yeah, kind of a coincidence, 136 there, so seems to jive. Now we're going to solve for how many moles of M2SO4. So we had 1 mole in our balanced equation of M2SO4, there you go, sorry, M2SO4, for every 1 mole of CaSO4. So in this calculation, we've turned mass of our final precipitate into moles of our final precipitate. We solve for moles of our initial compound that we must have had. Now we're going to convert that into grams of M2SO4. From 1 mole. Now the thing is, we don't know the molar mass of M2SO4. M2SO4. We don't know the mass of M, so we can't get a molar mass here. So we're going to call this a variable, X. But what we do know is that this number is 1.42, because that was the initial mass we were given of M2SO4. All right, so now we know all this. Now we can do a little bit of simplification here, and I believe what we end up with here is 0.00997, somewhere around that, moles of M2SO4 times X, and that's in grams per mole, that's our molar mass, is going to be equal to 1.42 grams of M2SO4. I see that well. Thanks. I'm almost done. Now we're going to solve for X. So X, in terms of grams per mole, is equal to 1.42 grams of M2SO4 divided by 0.00997 moles of M2SO4. And what we end up with is our molar mass is 142 grams per mole. That's about the only certainty we have here is 142. Now, what I do know here is that the molar mass of M2SO4 is equal to 2 times the mass of M. There you go. Sorry, I get my mass of M. Plus the mass of S, plus 4 times the mass of O. That's just how you get a molar mass. It's the sum of the masses of each individual component. But we know this number is to be 142. That's grams per mole. So 2 times the mass of M, our unknown, plus the mass of sulfate. Oh, Will's going to help me out here with his fingers. There you go. 96.06 grams per mole. We do a little bit of arithmetic here, and I believe we end up with somewhere around 23.2, I think it is. 23.2 grams per mole is kind of the molar mass here of substrate M. If we check our periodic tables, 23-ish grams per mole, where's sodium? 23 grams per mole. It's the group 1 metal. It's not lithium, it's 7. It's not potassium, it's 39. It's sodium. All right, so one more time. We did a normal stoichiometry calculation. We substitute x for our unknown. We're given every other variable. We solve for x. From x, we were able to derive the mass of the element. Right on. Good luck, guys.